Hello, everyone. Hello. So, this past year I went back to school, and over the summer I took 5 classes. That means I'm start my senior year now, which means next year I'll be back at Cubicle. As a result, I wrote this on the plane because I was so busy. After my finals, I left and I wrote this on a plane. This is my first run, so this is probably my worst talk ever. So let's get started. The growing influence of technology in cubing. In the past 2 years, a lot of stuff has changed. Technology has changed a lot. Hardware has changed, but not just hardware. Software has changed. And a lot of cool things have happened in the past few months. Both the GoCube and the Giiker Cube, however you pronounce it, was released almost simultaneously over the summer. And when we look at things in history and nature, there are a few things. There's convergent evolution and multiple discovery. In nature, whenever things are set up perfectly, things will just happen because they are the logical next step. So for an example is around the world, 2 different species, completely unrelated, turned into a crab-like structure. That's just because at high temperatures and pressures underwater, the crab is the most efficient form. Similarly, with multiple discovery, scientists, as they became more scientific and got more knowledge, the very next logical step was to make the next best discovery. Examples were oxygen, calculus, light bulb, and the crossbow. Where does that stand in cubing? So we go back and we see how these 2 things, this was made in Europe, this was made in China, and they both do similar things. They tell you your notation, your TPS, and they help you train. But the thing is, the software for these things weren't aimed at people like you, competitive solvers who want to improve at a high level. And this is just the beginning. This is just step 0.5. By the end of this talk, we're going to go over step 2 even. So I did a little teaser on Instagram like a few months back about my project, Argentum. Some of you might know I did this thing called Angstrom Research, and it has a theme with the Latin language. I like to name the things after Latin. Argentum is my newest software. What does Argentum do? Argentum pretty much does the same thing, except it uses computer vision instead of hardware to read all your TPS, all your moves, everything. All it requires is a really high-speed camera, almost perfect lighting, and you can use any cube. That sounds a little hard to do, but we'll go over that later. So Argentum, like I said, you do your solves in front of a camera, no matter what cube you use, and it gives you all these metrics. It can calculate the whole cube from just 9 stickers on one face. And you might be saying, how is that possible? Because most people only see cubes in states of OLL, PLL, and certain things. We ignore all the other colors. But if you really think about it, the states are finite, and to get from one state to another state, calculating it is simple and mathematic. The program can also extrapolate moves and states between frames. So let's say if your hand covers the cube, and there are a few frames where the cube is covered up, it can figure out the moves that you would have done between state A to state B just like a human, and it ignores stupid moves like F2, B2, D2, L prime, things like that. No, it extrapolates them like the human. And the next thing is, this software can detect instantly when there are misscrambles. So there's a whole lot of utility just for this software. But like I said, if GoCube and Giiker Cube are just step 0.5, this is about the same level as those, because there are a lot of significant issues with each of them. So with the GoCube and the Giiker Cube, you can't use them in WCA because of the utility for cheating. Also, you have to recharge it, and you can't use the cubes that you want. With Argentum, you can use the cubes you want, but you gotta shell out for the hardware. Like, you gotta buy the camera, and you gotta buy a tripod, you need a boom, you need lights. There's better solutions, and I'm gonna get to it. But first, let's talk about how Argentum works. I'm sure some of you have some questions. The software can ignore hands and skin, because hands and skin, they only take up certain pixel values in something called HSV pixel space. Now this is getting too scientific. Basically all you need to know is the software can look at your hands and your skin and completely ignore it, and it only looks at the cube as it moves around. I also have a video example in a little bit. The next thing is visual noise. If your camera, even though it's getting the frame rate, what if your resolution is bad or there's dust, things like that? This can actually use a special technique to get the colors and ignore all of the visual noise in the background. And like I said, it tracks the location of the cube. And this is very simple because cube shapes are very specific. You can isolate the contours and map the features and only look at the cube. So you can move this around and the camera will track you. So this is pretty cool. So one of the biggest challenges is colors. So here's the fun facts time. It turns out human eyes, we're a product of nature. We're not binary computer things. We actually are blind to a lot of colors. Humans, when we see colors like this, even though the frequency is really, really, really different, green all looks the same to us. Blue, similarly. So if light hits a cube at an angle, you're going to see some weird colored things, and the computer won't see the colors like you do. Argentum figures that out. Even though color distances are non-Euclidean, this will calibrate itself to your color scheme on the first frame, and then use those colors to figure out your cube and track it as you solve. So this is an early prototype. Sorry for the little thing. This was sent to my boss back when I was working on it. You can see that as I move the cube, the red square, that's not video editing. A computer followed that cube around and looked at the moves as it's being done. This is an example of how it can ignore all the background, ignore the skin and the hands, and then track your cube and get your metrics as you solve to help you train. And here's another example. You can see the color values that it's scraping. It identifies the stickers with the green outline, and it tells the space occupying with the red square. This is debug mode. This is how I know that it's actually working. And you can see that it's scraping the colors from here as it moves around. And this is just proof that Argentum works. But like I said, this is just step 0.5. But with all of these things, it comes with a big cost. You need the tripod, the camera, lighting conditions. How can we get better? So the next thing is computer vision also takes a really powerful computer. My computer runs at 4.2 gigahertz, and I'm still taking a few minutes to analyze a solve. Now, if we look at the other differences, GoCube and Giiker Cube, they just need a Bluetooth connection, a battery, and the basic software. Is it really worth having all these conditions just to track the metrics on your own cube? Well, it turns out I'm here to tell you, yes, you can actually have everything you want. Everything. And that's Argentum version 2. And we're going to use deep learning. Are there any computer scientists in the room? Oh, I see a few. So a lot of people are talking about deep learning as the next big buzzword because it can do a lot of things, such as if you used a traditional computer and you didn't code it right, you could give it some information that was a little bit off, and it wouldn't be able to read that. Scraping data from Rubik's Cubes, as we do it in video, is similar. Speed cubes, not Rubik's Cubes. Yes, as I was saying, so mapping out these contours, if you're off by a pixel, off by things, no matter how much you do it, it's incredibly computationally intense. Now, I'm going to give an example. Well, first, before the example, I'll explain deep learning. In deep learning, you have what's called a neural network. It's a bunch of nodes that send data to each other, and you can tell if it's learning it by if it's giving you good results or not. If you give it a big library of data, it'll go through the data and create an algorithm based on the data that you feed it. That's a big approximation, but that's pretty much all you need to know. I talked with Kerry Huang. I don't know if he's in here. Oh, there he is. He can explain it much better than I am. If you want to talk to him after, you can talk to either him or me. So I'm good at like the stuff I did before. I haven't done the next step yet, but I'm going over the theory, and it's definitely possible, and I'll give you an ETA at the end of the talk. So basically, by using deep learning and computer algorithms like that, you can have a level of uncertainty. And once I give you the example of how people actually use this, it'll make perfect sense. So historically, computation of faces was really, really intense on the computer. But now you have people using their phones, their iPhone X. My Microsoft Surface uses facial recognition. Facial recognition now is really, really fast. And the way it changed is because someone invented something called a Haar Cascade. We're not going to go over like what that is. That's math and annoying, icky stuff. But basically, someone invented something that made facial recognition better. Instead of having to map out the polygons, finding the ratios, checking a database, it was easier. But it still wasn't good enough. And that's because these were using traditional computer vision algorithms just like Argentum version 1. Now, someone then recently within the decade started using deep learning and neural networks to detect faces. And suddenly this was able to do in almost real time in human time standards. And you can recognize faces from several angles. You don't have to look up straight to the camera. The camera can tell your face as you're walking through a crowd, even parts of your face, and that's what we need. If this can scrape a video at any angle and even having pieces of data missing, that's the next step. And once I explain the next step, it's going to become so clear. Now, think about it. In these conditions, if you could get this program to just automatically scrape YouTube and look at videos and get all the metrics from every solve ever uploaded onto YouTube and append them to a big database, go through that database and sort them for the best algorithms posted by the best competitors. Competitors who might not ever post their algorithms now have all of their algorithms accessible to the internet for everyone to use. We are entering the end of secrets. Because once you can scrape all this information, you create a training program that watches you as you solve and then suggests to you better algs and improves you directly. F2L, cross, OLL, PLL, ZBLL, one look last layer, it will tell you everything based on all the information. Any alg that anyone uses at any competition will now be scraped by this program and shared to the world. That is Argentum version 2. Using deep learning and computer vision to improve everyone and spread the propagation of information to all. And you're probably wondering, what's the ETA? This sounds really cool. I'm still in school, guys, I'm sorry. And I'm still like working on cubicle projects. Shout out to Phil, he made this possible. And yes, cubicle projects such as gamma treatment, compound V, compound X, you can check that out at our room close to the yellow room 155. Those projects still have priority, and like combining that with school, other secret projects, we're looking at around 2019. So that's when I graduate college. We're here right now. I want to start working on the deep learning section by the winter, and by next year, hopefully, we can make this ready for the open public. And that's very tentative. But after I graduate, all bets are off. I can do this all day. So, thank you everyone. Are there any questions?